Hello everyone, welcome to the lecture series of KOE 039. The subject is digital electronics, which is covered in mainly all the branches of computer science, AI, ML, data structures, civil, mechanical, electronics and instrumentation branch. So the topic which we are going to cover today is the multiplexer or MUX. So digital circuits can be classified into two parts. Right? We know that digital circuits can be classified into two parts. First one is the combinational circuit and the second one is the sequential circuits. Is the sequential circuits. In case of combinational circuits, your output is the function of input applied at the present time only. But in case of sequential circuit, your output is the function of inputs applied plus past output. Okay. So if you check the block diagram of these two circuits, we have some inputs. In case of combination circuit, we are going to have some inputs and we are going to have some output. We are going to have some output lines. Okay. And in case of sequential circuit, this is the block diagram of combinational circuit. And for sequential circuit, we have some input lines, some input lines will be there, some output lines will be there, and some part of the output is stored and then again fed back to the input side, that is used to store the past output. Okay. So some example of these combinational circuits are adder, right, subtractor, MUX, multiplexer, demultiplexer, decoder, encoder, code converters, comparator. Okay, so these are some examples of the combinational circuit. And under sequential circuit, we have latches, flip-flops, registers, counters, and so many things are there under this sequential circuits. So first we are going to learn the combinational circuits. So these are combinational circuit. For example, adder. We have full adder. We have these three inputs, 1, 1, 1. We know that its sum will be 1 and carry will be 1, right? So irrespective of time, their value, they will give some value. Their output is not dependent on the present input. So that is why these are known as combinational circuits, where your output is dependent on the inputs applied at that time only. So the topic which we are going to cover today is the multiplexer. Multiplexer is also named as MUX circuit. It is a combinational circuit which that is given a certain number of data inputs. Let us say 2 raised to the power n, and where n will be your selection line, select inputs used as a binary number to select one of the data input. The multiplexer has single output which has the same value as selected at the data input. Okay, so multiplexer is a circuit which it is also known as many to one circuit. Okay, so multiplexer is basically a circuit. Okay, so we have n input lines and single output lines. Okay, now how many input lines we are going to connect? These are given by selection lines. These are given by selection lines, and the relationship between selection line and input line is 2 raised to the power selection lines is equal to number of input lines. Okay, so for a simple so this multiplexers are also known as data selector or parallel to serial converter or many to one circuit. It is also known as many to one circuit, and it is a universal logic circuit. Okay, this statement is very much important that multiplexers are universal circuit. It states that we can design any digital circuit with the help of multiplexer. So this is the simple multiplexer diagram, block diagram. So how we have drawn this diagram? So we have studied that 2 raised to the power selection line will be your number of input lines. Okay, 2 raised to the power selection lines will be equal to number of input lines. So 2 raised to the power 1 selection line, number of input lines will be 2. Okay, so we have 2 input lines. Okay, so here I'll draw. We are trying to make the 2:1 multiplexer. 2 input lines will be there. I1, I0, single output line will be there and single selection line will be there. Okay, so now I want, because of this single selection line, this S can be 0 or 1. Now we assume that if S is equal to 0, the data present at I0 line will be connected at the output line. So here Z will be whatever the data attached to I0 line, it will be connected to Z line. And next, when selection line is equal to 1, data present at I1 line will be connected to output line. Okay, so its equation, if you want to write the equation, it can be written as S bar, this S bar, whatever data we want to connect, I0 plus S I1 will be your Z, and we can make the circuit diagram of this. Okay, so this is the simplest multiplexer circuit. We can also design in a vice versa way that if your selection line is 0, I want I1 line to connect at Z line, and when selection line is 1, I want data present at I0 line should be connected at output line. At a time, single input line will be connected at the output line. Okay, so next is your 4x1 mux. Okay, this is the block diagram of 4x1 mux. So in this 4x1 mux, we are going to have 2 raised to the power 2 selection lines will be your number of input lines. Okay, number of input lines. So we have 2 selection lines, S0, S1, 4 input lines are there, I0, I1, I2 and I3. Okay, so for this 2 variables S0 and S1, for if it is 0, 0, I want data present at I0 line should be should be connected at Y output line. This I data, it can be logic 0 or logic 1. Similarly, for 0, 1, whatever the data present at I1 line, it will appear at output line. For 1, 0, whatever data present at I2 line, it will appear at output line. Similarly, for 1, 1, whatever data we are going to write, we are going to connect at I3, it will appear at output line, right? So to write the equation, we are going to write 0, 0 is represented by S0 bar, S1 bar, and the data line I0, 0, 1, I1, 1, 0, I2, 1, 1, I3. Okay. So we can make the circuit diagram using this equation. We have this selection lines, and we can see that AND gates are used. So we use 4 AND gates, okay, and we are going to connect input line at each gate, okay. Lastly, all the output from this stage is connected to have the single output. Here we can see that we have used the OR gate. So OR gate is used at the last stage, okay. So whenever you draw any circuit or realize any circuit, name the inputs in such a way that by checking the block diagram, we get to know that it is a circuit diagram for multiplexer, okay. So in case of multiplexer, we always prefer to denote selection line by the variable S, okay. Similarly, in case of adder, we always name it as A, B, carry in, sum and carry out. So by checking these variables, we can understand that it is the block diagram of full adder. So select the variables in such a way that by looking at these variables, we get to know that it is the block diagram or circuit diagram of multiplexer, okay. So now in the previous slide, I have mentioned one statement that your multiplexer are universal combinational circuits. It states that we can realize all the circuits with the help of multiplexer. Let us get to know how we are going to realize. So we are going to realize AND gate using 2 cross 1 mux, okay. So we are going to realize this. This is the truth table for AND gate. First write the truth table for the AND gate. 0, 0, 0, 1, 1, 0, 1, 1. For 0, 0 output is 0, 0, 1 output is 0, 1, 0 output is 0, 1, 1 output is 1, okay. So from the present, this is my gate, okay, with x, y, and function, okay, output which is denoted by f, okay. So from these variables, we have to pick some values, we have to select some values as a selection line. We will connect some variable at the selection line, and rest of the variables will be connected at the input, okay. So if you divide the circuit in this way, we can see that this x can either be 0 or can either be 1, and we know that in case of 2 cross 1 mux, we have the single variable x, we have the single selection line s, right. So this selection line we can use this x as a selection line, okay. So we use this x as a selection line. This x can be 0 or 1. Next, so this we have covered in a selection line, okay. Now y we are going to put it into the input side. So how we are going to find out the values? For 0 it is 0, for 1 it is 0. So the function will be 0, okay. Next, for 0 it is 0, 1 it is 1. So function is equal to variable y. So the first value I0 will be logic 0, I1 will be Y. Okay. So I0, in the place of I0 we have applied logic 0. Here you can write logic 0 and the second input will be Y. Let us quickly check the case whether this multiplexer behave as a AND gate or not. So we will consider the case X is equal to 1, Y is equal to 1. So we know that the value of function should be 1, right? In case of AND gate, both the values are 1, output should be 1. Okay. So let us check the quickly. So it is logic 0, here the value is 1, here I have 1. We know that when the selection line is 1, I want data present at I1 line should be connected to output line. So here I am going to have this value 1. So it behave as a AND gate. This 2 cross 1 multiplexer behave as a AND gate. Similarly, you can design any gate, even XOR gate, XNOR gate, with the help of these multiplexers. Next is we can implement. So now we have designed the 2 cross 1 mux, 4 cross 1 mux. Similarly, we are going to have 8 cross 1 mux. Okay, 8 cross 1 mux. In case of 8 cross 1 mux, we are going to have 3 selection line, right? 2 raised to the power 3 is equal to 8 input lines and 1 output line. Okay, so 3 selection line. If we have 3 selection line, we are going to design 8 cross 1 mux. If we have 4 selection line, we are going to have 16 cross 1 mux. So this higher order multiplexers can be designed with the help of lower order multiplexers also. So let us check how these multiplexers can be designed using the lower order multiplexer. So this is the example of 16 cross 1 mux using 4 cross 1 mux. So in the 16 cross 1 multiplexer, if we need to design 16 cross 1 mux, we must have the selection line. 4 selection line will be there, S2, S3, S2, S1 and S0. 2 raised to the power 4 is your 16 input lines, right? And these are my selection lines. So 4 selection lines I have connected. Single output line will be there, right? And here I am going to have 16 input lines. I0, I1 up to I15. Okay. So if you draw this block diagram, if you write its equation and you make the circuit diagram at the gate level diagram, it will be very much complex. So better approach is use the lower order multiplexer to realize the higher order multiplexer. So to realize this multiplexer, 16 cross 1 multiplexer, we are going to use this 4 cross 1 mux. Okay, these 4 cross 1 mux are used. Okay, so 4 cross 1 multiplexers are used here. Okay, so and selection lines are common to each multiplexer. Okay, so here we have position 0, 1, 2, 3. These multiplexer blocks are identical, so their positions will be same: 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2 and 3. Their position will be identical, right? We have connected the same selection line to all the multiplexer at the first stage. This is my first stage. All the selection lines are same: S1, S0, S1, S0, S1, S0 and S1, S0. Input lines are connected. Okay, we can see that input lines are connected from I0 to I3, I4 to I7, I8 to I11, I12 to I15. Total 16 input lines we can see at the input stage. Okay, so let us check one case when we have the 1 1 1 0 0, S3, S2, S1, S0. Okay, so output should be present. The output will be I12. Whatever data present at I12 line, it will appear at the output line, right? Because in a simple way, we have assumed that 0 0 0 0 I0 line will be connected, 1 1 1 1 I15 line will be connected at the output line. Okay, so let us start from this stage, and in the next stage we have 4 outputs from the first stage. All these 4 outputs will be connected as a input to the next stage. Okay, and in the next stage we are going to connect the rest of the selection lines, right? These two I have used as the first stage. Next, S3, S2 will be used at the second stage. Okay, so let us check this example. We are going to check this example. S3, S2, S3 is equal to 1, S2 is equal to 1, S3 is equal to 1, S2 is equal to 1. Here we have the 0 0. These values are S1 is equal to 0, S0 is 0, 0 0, 0 0 and 0 0. Okay, so when selection line is 0 0, from this first multiplexer, I0 will be present at the output line. So here I am going to have I0. For this 0 0, I4 will come at the output line. Next, 0 0, I8 will come at the output line. 0 0, I12 will come at the output line. Okay, so here I am going to have I0, I4, I8, I12. Now my selection line here are 1 1 1 1. So whatever input present at this third place, I12 will come at the output line, and the value of this I input, it can be logic 0 or logic 1. Okay, so this way we can realize the higher order multiplexer using the lower order multiplexers. Next is we can realize any combinational circuit with the help of multiplexer, right? So for example, we have to realize this Boolean function. We have to realize this Boolean function with the help of multiplexer. Let us check the method. One way to realize this, we have studied this Boolean function is either by using the Boolean algebra, second by using the K-map, third by using the tabular method. Now we are going to study this, how we can solve this with the help of multiplexer. Okay, so this is a 3 variable equation with all these values. Here we have output is equal to 1 and don't care is present at 7th place. Okay, so write the output first. So let us denote it as Z, and we are going to design this using 4x1 mux. Okay, Z, first write the output. Output is 1 and this 1, 2, 3, 5, 6 and 7. We can include or we can reject also. Okay, so first solve it by using the don't care. It's up to you whether you want to take it as a 1 or whether you want to take it as a 0. You can solve it in any way. Okay, so rest of the place we have the output 0. Okay, so check what is asked in the question. You have to realize this 4 cross by using 4x1 mux. Okay, so first thing, in case of 4x1 mux, we have we have two selection lines. We have two selection lines. Now, whatever parameter is present in the question, out of these three parameters, we are going to extract some as a selection line. We are going to use some as a selection line, some variables as a selection line, and some variable as a input line. Okay. So, if you see the chart, if you check the chart, we can see that if you use AB as a selection line, we need to have two selection line. If we have AB as a selection line, AB is either 0, 0, then 0, 1, then 1, 0, and then 1, 1, right? So, we have all four combination. AB is equal to 0, 0, 0, 1, 1, 0, 1, 1. Now, we are left with the variable C only. This C will be, these two are my selection lines. Okay, and this C will behave as a input variable. Okay, so when I divide this into 4 parts, because 4 cross 1 mux will have 4 input lines. We have divided the table into 4 parts and each part will give you one input variable. From here, I am going to have I naught, the value of I naught. So, check, see, for 0, output is 0, for 1, output is 1. So, I naught will be C. From these two, whatever the value of C is, output is always 1. I1 will be logic 1. Next, for 0, it remains 0. For 1, it remains 1. From these two, we are going to have I2 is equal to C, and let us assume that we have logic 1 at this place. Okay, if you assume logic 1, we are going to have I3 is equal to 1. We are going to have I3 is equal to 1 if x is equal to 1, and if x is equal to 0, if I assume for this one, यहाँ पे x है, x is equal to 0, we are going to have inverted values. I3 will be, for 0 it is 1, for 1 it is 0, C bar, if we treat I don't care as a 0. Okay. So, now we are going to connect it into the block diagram. We are going to connect it into the block diagram. We have the 4 cross 1 mux. 2 will be treated as a input, as a selection line. Here we have select A and B as a selection line, right? And 4 input lines are there. The values will be C, logic 1, again C, logic 1, or C bar if x is equal to 0, 1. If a don't care is treated as logic 1, and we have the single output line Z. Okay. So, this way we can realize any Boolean function with the help of 4 cross 1 mux. Okay. So, next is how we can realize any combinational circuit with the help of 4 cross 1 mux or any other multiplexer. So in this previous circuit, we can realize this same circuit by using 2 cross 1 mux also. If I want to use this 2 cross 1 mux, if I want to realize this circuit, this truth table as a 2 cross 1 mux, this equation is a 2 cross 1 mux, what we are going to do in case of 2 cross 1 mux, we have one selection line. Okay, so divide the table into 2 parts. First part, okay, here the value of selection line is either 0 or the value of selection line is either 1. Okay, so A will be treated as selection line in case of 2 cross 1 mux. Okay, B and C will be treated as an input, and divide the table into 2 parts. Realize this function with the help of B, C variable and connect the respective inputs at the block diagram. Okay, so we have A as a selection line, BC, some value of BC will be there at I0 and I1, and similarly Z will be there. Okay. So let us realize one combinational circuit, one last example, one combinational circuit with the help of multiplexer. Realize full adder using 4 cross 1 multiplexer. Okay, so first write the truth table for this full adder. Okay, so we have A, B, C in 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. With the help of these 3 variables, we are going to have 8 combinations. Outputs will be sum. I'll explain only for the sum terms, and carry you can try yourself. For 0, 0, 0, sum will be 0, carry will be 0, 1, no carry is generated, 1, no carry is generated, 1, 1, 0, 1 as a carry, 1, 0 as a carry, 0, 1 as a carry, 0, 1 as a carry, and 1, 1. Okay. So first write the truth table, and we are going to realize it using 4 cross 1 mux. Okay, using 4 cross 1 mux, first thing is we are going to divide this table into 4 parts so that we can have the 4 input values from these 4 divisions. Okay, so now select AB as an input line, as a selection line, because we can see that we have 0, 0, 0, 1, 1, 0 and 1, 1. So first thing is select AB as a selection line. Now C in, we are going to realize for the sum circuit first and then design for the carry circuit. So 2 circuits will be made, 4 cross 1 mux, AB. This will be for sum and this will be for carry out. First realize the sum. For 0 it is 0, 1 it is 1. So we have here C in. So from these two we are going to have C in. These we can see that they are inverted values. C in bar, again inverted values, C in bar and C in. Okay, so four input values will be my C in, C in bar by connecting one inverter. Third is C in bar. Third one is C in bar. Okay, and the fourth one is C in. I0, I1, I2, I3. And at the output, I am going to have the sum values. Okay. So for carry, I am going to write it with the red pen. I am going to write it with the red pen to solve the carry. So check for this 0, output is 0. For 1, output is 0. Whatever the value of input is, output is 0. Okay, so here I have logic 0. So here for 0 it is 0, 1 it is 1. So here I am going to have C in. Next for 0 it is 0, 1 it is 1, again C in. For 0 it is 1, whatever the value of C in is, the carry out is logic 1. Okay, so these red marked are for carry out. So here I am going to connect logic 0. Next we have the C in. Again I have the C in. And last I have the logic 1. So here I am going to have the C out. Okay. So in this way you can realize any circuit with the help of multiplexer. Okay. So if you need to draw the circuit for the subtractor using multiplexer, same approach will be used. So I hope you like this concepts. Thank you so much.